4,500 years ago, in the desert outside Cairo, a civilization erected a structure so mathematically demanding that modern construction equipment struggles to replicate it. It stands 481 feet tall, composed of roughly 2.3 million stone blocks. Some of the granite beams used in the upper chambers weigh up to 80 tons. Despite this massive scale, the blocks fit together with sub-millimeter precision. The entire base is oriented to true north, with an accuracy of 0.05 degrees. Mainstream models point to external earthen ramps, but to reach the upper sections, a straight ramp requires more material than the pyramid itself. These models focus on raw labor, dragging heavy limestone skyward, treating the build as purely brute force logistics. Ancient Egypt possessed the bureaucratic organization to manage this scale of labor. The Wadi al-Jarf papyrus contains the actual administrative ledgers documenting workers transporting stone down the Nile. Documenting how a stone was moved, however, does not explain why it was placed to fractions of a degree. A work crew dragging an 80-ton block up a wet dirt ramp does not produce a zero-tolerance joint by accident. This 3-inch ivory statue is the only known portrait of the pharaoh Khufu. It is a modest artifact, standing in contrast to the geometric consistency of the monument attributed to him. By focusing on the mechanics of pulling stones on sleds, traditional research misses the engineering puzzle. The structural tolerances indicate the builders were creating a functional, calibrated system. The ARION Hypothesis applies first principles physics to these anomalies, examining the structure exactly as it exists today. If we move past the assumption of a purely funerary monument, the internal architecture begins to behave like an engineered machine. The king's chamber is built entirely from Aswan granite, a material transported over 500 miles downriver, specifically for its physical properties. Granite has one of the highest acoustic reflectivity ratings of any natural stone. In a sealed room of this material, sound waves reflect rather than absorb, turning the chamber into a resonant cavity. The length of the chamber acts as a physical boundary for sound. When low-frequency energy enters this 10.45-meter space, the waves reflect to create a standing wave. At these specific dimensions, the geometry forces the atmosphere inside to vibrate at approximately 8 Hz, a frequency aligning with the Earth's electromagnetic pulse. Maintaining this level of frequency precision required a fixed calibration system. The builders utilized the only absolute coordinate system available to them, the night sky. Laser surveys of the 4 internal shafts revealed a point to specific stellar coordinates from 2500 BCE. The southern shaft locks on to Al-Matak in Orion's belt, while the northern shaft targets Thuban, the ancient pole star. A room lined with acoustically reflective stone, precisely dimensioned to an earthbound frequency and pinned to fixed stars, points to a deliberate design. The structure is calibrated to interact with physical, earthly, and cosmic forces. This calibration required the builders to solve a massive logistical problem, placing 80-ton granite beams hundreds of feet in the air to sub-millimeter tolerances. Standard Egyptian stone extraction was a brute force process. Workers pounded trenches around bedrock with dolerite stones, wedging out massive, irregular chunks to be finished later. Chemical analysis of certain construction stones has found profiles consistent with geopolymer concrete. This suggests that instead of dragging solid blocks, the builders may have chemically cast the stone in place. Casting stone in a mold resolves the joint precision problem. The wet material naturally settles into every crevice, achieving a flush edge that is nearly impossible to carve by hand. This method helps explain a complex geometric feature. The Great Pyramid is not a simple 4-sided structure. Each face features a precise 94-centimeter indentation down the middle, creating an 8-sided geometry. Being so subtle, it's invisible from the ground, becoming apparent only from the air during equinoxes, when the setting sun splits the faces exactly in half with shadow. Using synthesized stone to build a functional solar calendar suggests the builders were operating as master geometricians and chemists. The ARION model is an investigation into high-level human engineering, relying entirely on physics, chemistry, and astronomy. It suggests that ancient Egypt possessed a scientific framework where physics, astronomy, and material science were integrated into a single discipline. The loss of institutions like the Library of Alexandria suggests that technological history isn't always a steady climb. It indicates that entire systems of integrated knowledge can be fragmented or lost, leaving behind architectural peaks that we struggle to explain. The Giza Plateau represents one of these peaks, a concentration of cosmological engineering and harmonic science that was later fragmented. Today, the geometric silence of the plateau stands against the sprawling concrete of the modern city. We build for immediate expansion and utility. The builders at Giza left a record of their understanding in the masonry itself, encoded in the standing wave of the king's chamber and the alignment of the shafts. For millennia, this structure has stood in the desert, a physical artifact of a physics-based paradigm we are now developing the instruments to recognize.